So, why is the spontaneous activity so important?
We really want to know what it's for. Just like the problem with the individual neurons responding to the outside world, most of our models of how the brain works are based on neuron sending spikes because they're encoding something. Either they're encoding something happening in the outside world to them, so some pictures, some sounds, some smells, or they're encoding something that's about to happen. So they're encoding some movements of the arm, leg, eye, head, whatever. But with so many neurons sending spontaneous spikes, we don't really have a good, strong theories of what those are for. And particularly in cortex, it seems that those spontaneous spikes are generated by the circuit itself, by the feedback between the neurons. And what this suggests, of course, is that the spontaneous activity must be doing something important. So in the book, I give essentially two general answers to that question. So one reason for having spontaneous activity is to solve a problem of the fact that individual neurons are quite sluggish in their response. So as I said at the top of the podcast, how neurons send their spikes because they have to get tens or hundreds of inputs from other neurons enough to drive their voltage up to create a spike. And that process can take quite a long time. So if we need to get some information from the outside world, from the eye all the way to the prefrontal cortex in a matter of tens of milliseconds in order for us to react to it properly and make some decisions about it, then we can't rely on neurons going from their sort of resting state all the way up to creating a spike in the something like 7 to 9 different regions of the brain that those spikes would have to jump through, because that might take seconds, if not a couple of minutes. And we've only got tens of milliseconds in which to process this stuff. So one good reason for having spontaneous activity might simply be because that forces the neurons under this constant barrage of input. So what that does, it forces the neurons to always be close to the point where they're able to send a spike if they need to. It's simple then to show that kind of idea that you can then transmit spikes very rapidly through the brain, because every time say a stimulus is shown to your eyeball, there will be neurons ready to respond at the back of the eyeball almost instantly, who then send spikes to the first area of visual cortex. That first area of visual cortex, there'll be a whole bunch of neurons that are just about ready to send their spikes. That input arrives, they send the spikes immediately. Into the next area of cortex, the same, the next area of cortex, the same, the next area of cortex. So each wave of output instantly triggers a response. And you have this whole barrage of information being passed through the brain in a matter of tens of milliseconds as opposed to seconds or minutes. Now, it's a terrific theory, but it also has a slight downside, is that it's really quite prosaic in the role it's positing for spontaneous activity. Because after all this, generating all these millions and probably billions of spontaneous spikes every second is extremely energy intensive. And to do that just in case you need to respond to something quickly seems to be an extraordinary use of energy. The other main idea I explore in the book about why they exist is because they actually are doing some kind of computation themselves, or that computation is some kind of prediction. So we have very well rehearsed high-level theories about the predictive brain, about predictive processing, stuff that sort of Andy Clark write books about, and lots of people write theories about how brains may, in theory, do predictive processing. There is very much less, though, on how brains actually do predictive processing. So my solution to how they actually do it is that the spontaneous activity the brain generates anyway has been co-opted to do this predictive processing.
What else would you like to share before we close?
So the spontaneous activity part in particular, the idea that it does predictive processing is this idea that most of the things that we see that the brain does, things where we seem to be able to respond to changes in our visual world very quickly, about how we can remember things well, about how we make decisions quickly. These are all due to the fact that spontaneous activity is there in the brain, creating the conditions in which they're predicting what each of those things is going to be in advance of them being used. And partly that's just taking advantage of the fact that our brains are huge, so we can give over all this huge amount of resources to this predictive stuff, even if the prediction never comes true.